Woo. All right, so we're on example 3.
You have audio too?
Yes. I'm trying. We got new things. Example 3, so if you're not able to see it on your notes, it's got find y prime if x cubed plus y cubed equals 6xy. This makes that pretty picture, the folium of Descartes.
I think it's Descartes.
Thank you. I think it's French.
It is definitely French.
Descartes is how we say it here in Texas. Okay, so find y prime if x cubed plus y cubed equals 6xy. This is our setup here. I want to do this one piece at a time. Okay, so we may have to come back and look at part B and part C in a little bit. All right, so for part A, find y prime if x cubed plus y cubed equals 6xy. Okay, I like that they switched to y prime. Prime notation is really kind of where it's at for me. So in order to do this, we looked at notes yesterday. We're going to take the derivative of each piece of both sides in terms of x. Okay, we're differentiating everything by x. When we take the derivative of anything not x, we have to multiply by that in terms of x, which would be dy dx or y prime. Okay, so every time I take y, the derivative of y, I'm going to write times y prime. Cool beans? Okay, so the derivative of x cubed, we're going to have 3x squared plus 3y squared times y prime. 3y squared y prime. Equal to, on the far right side, this is a product. This is a product. Can you tell? So we're going to have 6. I would say you're wanting to do the derivative of the first. Let the first be 6x. Okay? We want to do first times the derivative of the second, actually. We always start with the first. So first is going to be 6x times the derivative of the second, which would be 1 y prime, because it's a y. So we're going to have times y prime. Okay? Plus the derivative of the first, which would be 6 times the second, y. Everybody okay with that? And then our instructions here say find y prime. So now you have this big equation. We want to move everything that has y prime to the left and everything that doesn't to the right. Okay, so we're going to push this 6xy prime over here. And we're going to move this 3x squared over here. And so we're going to have on the left negative 6xy prime plus 3y squared y prime equal to 6y minus 3x squared. Everybody okay with that? We're following? Life is good? What is the benefit of putting everything on one side that has y prime and everything on the other side that doesn't? You can factor it out. Okay, that's always going to be the move here. We're trying to factor out y prime so that we can isolate it. So when I pull y prime out of both terms on the left, I'm left with negative 6x plus 3y squared equal to 6y minus 3x squared. Good? Okay. Now we want to isolate y prime even further by dividing by all of this in parentheses. So y prime is equal to the ratio 6y minus 3x squared over negative 6x plus 3y squared. Okay. They simplify in the textbook. They drop everything down by 3 because you've got 6s and 3s. So if you do that, if you simplify and reduce everything by 3, you end up with 2y minus x squared over negative 2x, negative 2x plus y squared. So that's part A. That's part A. Are we good with that? Okay. So then we want to go to part B, which says find an equation of the tangent line to the who's it, what's it, at the point 3, 3. Okay, find the equation of the tangent line at the point 3, 3. So in order to write the equation of a tangent line, we need some pieces, right? We need a point, which we have. We're going to use the point 3, 3. And we need slope, f prime, which we've called y prime, right? So from part A, y prime is 2y minus x squared over y squared minus 2x, or negative 2x plus y squared, right? And so in order to find the slope at this point, 3, 3, we're going to need to plug in our 3 and our 3 for both x's and y's into that slope function. So we've got 2 times 3, and I lied, it's not a slope function, it's just a slope something. What is the word? Jeez Louise. It's very tricky. So I got 6 minus 9 would be negative 3 on top. And 9 minus 6. So my slope's negative 1. Slope is negative 1. So now we use our point. So y equals mx plus b. 3 equals negative 1 by 3 plus b. Seems like y equals negative x plus 6 is the equation of that tangent line. I took a picture of that on my phone yesterday from the book, and it seems like it's a pretty accurate picture. Yeah? Okay. All right. So that's part B. We also need to do part C here. Okay. Part C, so I'm going to take out this picture so we have some room. For part C, it says find the point in the first quadrant at which the tangent line to the thingy is horizontal. What does that mean?
Please pardon for this interruption. Teachers, please send the following...
Where the tangent line is horizontal. So where the slope is 0, right? So if it says tangent line horizontal, we need to set y prime equal to 0. And we need to solve for what that looks like, okay? We know that when we set a ratio equal to 0, the bottom goes away. Because I'm going to multiply both sides by the bottom, and it's going to cancel itself off. So really, when I'm setting this thing equal to 0, I'm just setting 2y minus x squared equal to 0. Okay. The problem here is that I have bivariate data. I have both an x and a y. So you need to pick one. I would solve for y here because it's not squared. That's going to allow me to not have a square root something in my problem. Okay, so isolate one of your two variables. I would isolate y in this case. So we're going to add x squared to both sides. Now I have 2y equal to x squared divided by 2. So y equals half x squared. What that tells me is I have a tangent line horizontal when y is equal to half x squared. What does that mean for x? So we need to take that information, that y equals half x squared, and we need to go back into our original function here, x cubed plus y cubed equals 6xy, and we need to find out what does that mean for x? What is the x value when y happens to be horizontal? Everybody okay with that? Okay.
Wait, why are we able to do that if we're finding that for y prime and plugging in that back into just y?
So what we know based on y prime equal to 0 is that it happens when y is equal to half x squared. We don't know what x is at that moment. Does that make sense? We know that our tangent line is horizontal when y equals half x squared.
So we're going back to the original equation. Are we going to plug that in for x every time?
We're going to plug this in for y every time. And then we'll have some kind of x something that we can operate with. Okay? We'll come back to this y business in a minute. When we're find the point in the first quadrant at which the tangent line is horizontal, we need both x and y. So we'll come back and deal with y in a minute. But for now, we know that this happens when y is half x squared. So we're going into our x cubed plus y cubed equals 6xy equation. But instead of y, we're plugging in half x squared.
So we're going to cube that?
Uh-huh. Yep, cube it, not square it. So the way this starts working is x cubed plus half of x squared cubed. I'm going to square the half or cube the half as well. 1/2 cubed is 1/8. Good. 1/8. And then x squared cubed. When I raise a power to a power, multiply them. So 2 times 3 is 6. 1/8 x to the 6th power equals, here I have 6 times a half. Let that be 3. You with me? Okay. 6 times a half is 3. X what? X cubed. Because I did x to the first times x squared. Multiply like bases, add my powers. Okay. So we're rocking along here. I would swing this 3x cubed to the other side.
So it's all equal to 0?
So we set it all equal to 0. We're trying to solve for x here. So x cubed minus 3x cubed is going to leave me negative 2x cubed plus 1/8 x to the 6th. Trying to set it equal to 0, trying to solve for x. So what do we have? How do we get x by itself?
By negative 2 and also 1/8.
You can.
Oh no, we can't do that.
Can't
We
you
have to pull something.
isolate?
Factor out what? Yeah. What would you pull? X cubed. X cubed. Pull an x cubed out of both terms. So that leaves me negative 2 plus 1/8 x cubed. When I divide by fractions, I subtract the powers. So 6 minus 3 would leave me 3 equals 0. So the first time that this happens is when x is 0. X cubed equals 0. That means x equals 0. But if you read back up here, it says find the point in the first quadrant.
That's not.
Well, it's going to be 0 comma something, and 0 is not in the first quadrant. 0 happens to be on the y-axis. Okay, so this first instance for x is thrown out because it's not in the first quadrant. Questions on that? So now we need to solve this other piece of information set equal to 0. I'm going to say 1/8 x cubed is equal to positive 2. Basically swinging that 2 across. Multiply both sides by 8. X cubed equals 16. So x is equal to the cubed root of 16. I think it's easier if we call it 16 to the 1/3 power. You with me? This is the x value when the tangent line is horizontal. How can we find the y value? So we're looking for a point. We know the x value of our point is going to be 16 to the 1/3. We don't know the y value for when that happens. So we're going back up here into this function. We're going to have y equals 1/2 times 16 to the 1/3 squared. In other words, half of 16 to the 2/3 power.
Where is this equation coming from? Right here. Okay, I got it.
Half of 16 to the 2/3. And I would put parentheses around that 16 to the 2/3 so you're not so instant to call it 8. You can't do half of 16. Can't. Because it's 16 to the 2/3 power. What that is that's the cube root of 16 squared. I got nothing. I don't know. But that's why I told you put parentheses around that so you don't call it 8 to the 1 to the 2/3. We could find that number. You'd have to use your calculator to get there.
How do you cube this in a calculator? I forgot.
You do the control and it's the nth root. Okay.
Oh, yeah.
I think this is like 2.5 something. I took a picture also from the textbook of this one.
Oh, I got 6.3.
Mm-mm.
I'll just do 16 to the 2/3 power. I also got 6.35 again, which is 16 to the 2/3 power.
Half it.
Oh yeah, half. Okay. Yeah, 3.15, 3.18. I guess.
Okay, so I took a picture here. It's not 3. It should be 2.53.
Oh.
2 to the 5/3. So they left it in fraction form here. I think if you put both of these answers that we see in this textbook in decimal form, you would get the numbers that you're getting right now, Cohen. Look at your picture right here that I've just put on the board. This shows exactly where that tangent line happens to be horizontal. 2 to the 4/3, which is going to be 16 to the 1/3. Those are equal. And then comma, half of 16 to the 2/3 power is 3.175. Is that what you got, Cohen? So when I did it decimal form, I got 2.52, comma, 3.175. Okay, that's a fully loaded problem. Fully loaded. It's got parts A, B, and C. Any questions on that one before we go on to the next example? Okay, so here is the next example, is example 4. This isn't quite so nasty. It says find y prime if sine of x plus y equals y squared times cosine of x. So here's your problem. Find y prime if sine of x plus y equals y squared times cosine of x. Okay, so I notice a couple of things that we want to write down before we get started. On the left side, when I'm taking the derivative of sine of anything besides x, what kind of a derivative operation am I going to do here? Yeah, this is going to be a chain rule. So right here, sine of x plus y squared or sine of x plus y, this is going to be a chain. And on the right side, where I have y squared times cosine of x, this is going to be a what? Product. Okay, so just sometimes better to game plan before you get started. Okay, so we have an equation here. We have sine of x plus y equal to y squared cosine of x. And our job is to find y prime. So when I take the derivative of sine of x plus y, what is the derivative of sine? Cosine. Cosine in terms of the inner function, cosine of x plus y, times the derivative of the inner function. So I'm going to take the derivative of x, 1, plus the derivative of y, which is y prime. Yeah, it would be 1. If there was a coefficient of y, it would be whatever that number was. It's just 1, so we'll call it 1 plus y prime. Everybody okay with that? Equal to, and our product on this side is going to be first y squared times the derivative of the second, which we're going to call negative sine x. Thank goodness that's not a chain. Plus the derivative of the first, which is going to be 2y prime, times the second, cosine x. Had to squeeze it in really tiny right there. Before we move it, here's what I would do. We have cosine of x plus y times a binomial 1 plus y squared, or y prime. We want to push this piece through the binomial, distribution style. So cosine of x plus y times 1 is going to be cosine of x plus y times, call it y prime, cosine of x plus y. So we're multiplying this cosine x plus y through that binomial. Equal to negative y squared sine x. Why is it negative? Yeah, I moved that. Plus 2y prime cosine x. Now, anything that doesn't have y prime, you want to push to the right. Anything that does have y prime, you want to push to the left. Okay, so I'm going to take off this guy. And I want to take off this guy.
But why are you able to subtract that if they're multiplying?
That's what I thought too.
Oh, because I kept my time sign, this should be a plus right here. This should be a plus. When I distribute it, I should have cosine x plus y plus y prime. Yeah. Good question. Bad algebra. All right, so on the far left, I've got negative 2y prime cosine x plus y prime cosine x plus y equal to negative y squared sine x minus cosine of x plus y. That's a y squared right there. The reason we push it all to the left is so that then we can factor out y prime. Okay, so now I have negative 2y cosine x plus cosine of x plus y equal to negative y squared sine x minus cosine x plus y. Everybody still okay? After we factor out the y prime, divide by the junk. Everything that's over there. Kind of the same process every time. It's just nasty. So y prime equals negative y squared sine x minus cosine of x plus y all over. They did the cosine x plus y part first in your textbook. I think it's conventional to start with whatever's positive and then subtract, but I really don't think it matters. We've got it all together anyway. Why don't I get to cancel this cosine x plus y and cosine x plus y on the top and the bottom? One's negative, one's positive. Also, they're subtracting and adding. They aren't multiplying by those, so they're not common factors that I could cancel by dividing. They're not common factors, so they don't get to cancel. Okay?
So that's our answer.
That's our answer. Are you proud of it? It's a wonderful little answer.
Yeah, I don't think one number's into that.
Let's put it in purple. Purple box. Everybody good with that?
Wait, why can't you cancel cosine?
Because they're not adding, or I mean, they're not multiplying. If this had parentheses here and parentheses here, you could cancel them, right? Because you would have this function times and times and times. You can cancel when you're multiplying. You can't cancel when you're adding or subtracting. Okay? All right. Let's see how far we can get with the next one. This is example 5. What time is it? 15. We got 10 minutes, y'all. This is happening. We're going to get there. Example 5. First and second derivatives. So find y double prime. If x to the fourth plus y to the fourth equals 16. Find the second derivative. If x to the fourth plus y to the fourth equals 16. Just FYI, what we're dealing with here is what they call a fat circle. So I want to show you, this is slide 6. This is graph of a fat circle.
No circle.
Y'all see it? Graph of a fat circle says, notice that it is stretched and flattened version of the circle. Therefore, this graph is often called a fat circle. It's a rounded square, also known as a fat circle. The graph is very steep on the far left and far right, but is quite flat in between. Okay? So just wanted you to see the function before we actually start taking derivatives here. So we are dealing with x to the fourth plus y to the fourth equals 16, and we're supposed to be finding the second derivative. So we got to find the first derivative first. Okay? So in order to do that, we're going to differentiate. We've got x to the fourth plus y to the fourth. So that's going to be
4x to the third plus.
I don't know. My brain hurts if I don't write down the function first. So that's what that was. 4x cubed plus 4y cubed, what? Y prime equal to 0. Good. Don't write 16. Resist the urge to not differentiate the other side. Okay. And now we want to iso y prime. So we're going to subtract 4x cubed. So 4y cubed y prime is equal to negative 4x cubed. Y prime is equal to, those 4's get to cancel. Again, they're common factors, right? They're multiplying them both on the top and the bottom. So we get to cancel the 4's. Y prime then is negative x cubed over y cubed. Good? Okay. Now, we're going to take the derivative again. Quotient rule. Good. Because it is a quotient. So this being a quotient means we're going to use the quotient rule. Low D high. So y cubed times the derivative of negative x cubed.
Which is negative 3x squared.
Squared. Good.
Minus
Minus
high.
high. So watch this. Negative x cubed. You better put that negative on your x cubed. Minus high. I promise that's a heartache waiting on a place to happen. Minus high. D low.
3y squared y prime.
3y squared. Y prime. All over. Square the bottom. Y cubed squared.
So y to the fifth.
Y to the sixth. Multiply powers. When I raise a power to a power.
Oh, got it.
Yeah. Okay, my only issue here is we have y prime in the top. Can't have a y prime in my derivative. Okay, so we're going to have y double prime equal to y cubed times negative 3x squared. So let's clean that up a little bit. Let's call it negative 3x squared. Y cubed. That's that first term. Everybody okay with that? That's this guy. And then a negative times a negative makes a positive. X cubed. Let's let it be, pull that 3 from that y squared.
3x.
So positive 3x cubed. Are y'all with me? Positive 3x cubed y squared. And then instead of y prime, what do we know y prime to be? This guy right here. So we're going to have negative x cubed over y cubed. And then all over y to the sixth. Okay. And now comes the fun part. We're just going to simplify for the rest of our lives. We've got 5 minutes to get to 5 minutes to get to the final answer here. So what happens here? Let's look at it. When they multiply this y squared, I'm looking at the second term, okay? When they multiply this y squared right here, let me get a new color so you can see better. When they multiply this y squared and divide by y cubed, you subtract your powers. So you're going to have a y on bottom,
Oh, that's okay. That's
okay?
really cool.
This is going to end up with a y on bottom. Is that making
Does
sense?
it go to the bottom of that fraction, or is it like a new one with power?
So let's rewrite it. Let's just rewrite the first. We've got y double prime equal to, So negative 3x squared y cubed. This little tail's in my way here. Plus 3x cubed y squared. Okay, we're going to handle that. This is negative 3, right? Because that's going to be 3x cubed times negative x cubed. What's that going to be?
Negative 3x.
Okay, so instead of writing plus right here, I'm going to change that to be minus
3x to the sixth.
3x to the, when I multiply like bases, I add my powers. So 3 by 3 is 6. When I divide these y bases, that goes over y. You with me? All divided by y to the sixth. This is a complex fraction. And I can't subtract on the top without having a common denominator. This guy has a y on the bottom.
Multiply that by y.
Multiply this second one, the first one, by y over y. Are we seeing that? So what does that do to the top? Negative 3x squared y to the fourth. We're multiplying by y over y. So when I multiply this y cubed by this y,
I had it as y squared instead of y cubed.
now I get y to the fourth. All over y minus 3x to the sixth over y. All over y to the sixth. Yeah?
Yes.
3x squared times y to the 4th minus 3x to the 6th. I could condense all of that into one fraction. In which case I can factor out something really dandy from this piece of information. What could I factor out?
3x squared.
3x squared. A negative 3x squared, actually. I can factor out negative 3x squared. Things have gotten a little sideways. When I pull that negative 3x squared, what's left in the top?
Y to the 4th.
Y to the 4th
Minus x to the
minus x to the 4th. Wait, I pulled a negative 3x squared.
So it would just be
Plus x to the 4th. All over. If both of these are divided by y, I can send that y to the basement. Okay. So y to the 7th. Y to the 7th.
Is there more simplification?
Yes.
Watch.
Watch this.
Well, they're all being multiplied by that y.
Look at this piece right here. This piece that says,
Oh, yes.
hold on, we're nearly there. This piece right here. Y to the 4th plus x to the 4th. What is that? Look back at your equation.
Oh, that's our.
Y to the 4th plus x to the 4th is 16. So the last simplification here is to take that out, that y to the 4th, x to the 4th, and plug in 16. So when you simplify, your final answer is negative 48 x squared over y to the 7th. Negative 48 x squared over y to the 7th.
Now, like,